Good afternoon, everyone. Welcome to Takeo Tuesdays, this week's webinar. That didn't come out quite right. Brett Zerba here, high above courtside at the Boston Garden. Just kidding, just kidding, just kidding. I am sitting at my home office desk. I am going to be going solo today. Hopefully everyone, Dave says hello, so I think that means people can hear me. So hopefully folks can hear me and see me. If a couple more people want to say hello or raise their hand, that'd be great. But I'm sure technology is working. And John from Norwalk, Connecticut. I grew up in East Hartford, Connecticut. My mom still lives there. Dad worked for Pratt & Whitney, United Technologies, for many, many years, right there in East Hartford, Connecticut. There used to be an airport there, believe it or not. Crazy times, crazy times. Now the Rensselaer Fields there, where the UConn football team plays, and they have other events there. My mom, when they have concerts there, my mom can hear the music playing, or the national anthem when it's a football game or some other event that would have a national anthem before it. Anyways, Colorado checking in. Hey, Corey, how you doing? I think Corey works for a company. His last name's the same name as the company, so I wonder how that worked out. We shall see. So anyways, welcome to this week's webinar. I will cover a lot of ground with this tool and show you where you can download it from. I spelt it wrong. Sorry, Corey. Oh well. When you get old, things like that happen. I'll show you where you can download it. I'll give you some tips and tricks with the software. There's videos online and whatnot. But a little history about Takeo, a 105-year-old privately held company, third generation, currently held by the current owner is Johnny White Jr. Great guy. He's a great guy. I've had the pleasure of spending some time with him off the clock, I guess I could say, and I have nothing but positive things to say about that gentleman. And hopefully some folks on the call have had the opportunity to meet him as well. He's a great guy, and the leadership team led by Cheryl Merchant at Takeo has done a wonderful job. Recently, the expansions we're going through, millions of dollars, upwards of 50 to 60 million dollars, maybe even more. We put on the books last year for expansions, and our facility, our welded products facility in Fall River, Massachusetts. Headquarters, world headquarters for Takeo is located in Cranston, Rhode Island. Little old Cranston, Rhode Island, which is it borders Providence, Rhode Island, the capital of Rhode Island. Not that Rhode Island's that big. I think it's 45 by 40 miles or something like that, with a big body of water in between, splitting it in half, not in half, but anyways, the Narragansett Bay. It's quite the state, It is a New England state. That'll be the quiz at the end of it. Someone's going to have to type in the 6 New England states, and I'm going to give you a clue. New York is not one of them. anyways, I don't even know what I was talking about. Oh, the addition at the Fall River facility is phenomenal. They're already it's already busting out in the tanks that they are making down there. Tanks a lot. They are doing an incredible amount of work for our industry and whatnot. It's just unbelievable. So today I'm gonna show you how to use this software and how easy it is to use. Trust me, if this guy talking right now can use it and pick it up, anyone on this call can pick it up almost as quick as I did, if not quicker. It's very, very easy to use and very intuitive. And it's really a tool in the version we offer to the industry, free of charge. You can download it from our website. Matter of fact, let me show you that right now. If I open up our website here, I hope. Takeo Comfort Solutions. Visit site. And I'll tell you, it's different every time I go to it. Of course, I want to visit the site. Software, right there. See what it says, software? HSS, Hydronic System Solutions Software. You click on that. Oh, good God. Let's close that down. And right here, By the way, it does need to reside on your computer. It's not a a web-based program. It is a standalone program. You'll get an icon on your computer that'll be there, and that's what you need to open each time you need to use it. So just beware. You may need to let your IT department know that you're running an executable file. I think I don't know. I always have to let IT know whenever I have to download it or whatnot. And I'm sure some of you folks know what I'm talking about. It is a Windows-based program. It is a Windows-based program. So just keep that in mind in that regard. But as you get familiar with it, you can see what the software can do for you. So right here, I'm representing a heating system, right? A simple 4-story building, very simple, as you can see here, right? It might have a little dedicated outside air unit running out of the mechanical room. A couple of boilers shown here, right? Some green product. We like green product, as you can see, but it'll help us size the pipe, size the pump for flow and head. It gives you a nice colored output. The 2 pieces of information I'm going to have to put in, or you're going to have to put in order for it to do its calculations, is the load or the size of, in this case, a fan coil. Forgot to have my water with me. Oh, there's a water. I might need that. Water. Anyways, you can see here I put in a very relatively small fan coil. I think I'm representing a hotel in this case here. But you do need to put in the load in BTUs per hour, okay? And there is you can switch it to metric if you'd like, but nonetheless, I'm just going to stay in the English units. Anyways, and then you do need to put in pipe lengths, and if you put in those 2 pieces of information, the software will run all these calculations for you very, very quickly and help you start building your design. Okay, and I can't emphasize how quick you should be able to do this once you get used to it. Okay, and you know, you can use it for presentations, you can use it for your own design work, you can make an MEP drawing or put it in your package. You know, you can actually save it to a DXF file if you'd like. And so you have a lot of opportunities here to get a lot of information very, very quickly. And as you can see, you can also do a chilled water, and you probably, hopefully everyone's, there aren't any colorblind folks on the call, but nonetheless, it is showing a blue pipe in this case because the pipe, excuse me, it's a chilled water system. And notice if I zoom in, the piping is actually shaded. Okay, so below 50 degrees, it's dark blue, and above 50 degrees, it's light blue. So just keep that in mind, as you can see there. And I'm gonna, I'm gonna show you quite a bit of details very, very quickly, and I will be monitoring the questions as I get going here. So let me get going. There are no handouts today. Oh, and just remember, in about 24 hours, you will get an email with your certificate. If you'd like, you can download, as well as the recording. We are recording this, so keep that in mind. Behave yourselves, in other words, behave yourselves for a change, I'm just kidding. Anyways, if you look up top here, a lot of these icons are very familiar to most of us, if not all of us. And then, you know, these, I'm scooting around up here, file, edit, view, and whatnot. And then the next row of items here are really different types of systems or stuff that you can use, okay? And so I'm going to stay with the Hydronic and Hydronic 2 tabs. So Hydronic tab gives you access to a bunch of equipment here. And like if I put my cursor over this one, it tells you what it is. You click on the down arrow and you notice all the different pictures you can get here, and you can drag and drop one onto the screen very easy. I'm going to do this again very shortly. So just keep that in mind. Oh boy, the old circle of death. All I was trying to do was delete it. Anyways. And then we will spend some time in the wizard, and this is top secret here, the wizard. This allows you to design a bunch of things very, very quickly, and I'll show you what I mean by that towards the end, or the second half of the presentation. These other units here, these other tabs allow you to design different types of systems, as you can see, okay? But these are not hydronic systems, so they are not active in the Takeo version of the software. You would have to go to the HVAC solution website, and I might be able to do that when we get to the end of the presentation and show you how you can download a sample, one that you can utilize and try to see if you want it for future things. The company that we partnered with to write this software, HVAC Solution, located in Salt Lake City. We're the partners now for somewhere close to 25 years, roughly. But they do charge for the version that allows you to design other types of systems. Okay. So, anyways, let me get a new sheet of paper. Right, file new, right? That file new, whatever. Isn't there a new right here? I just clicked on the icon, and as you can see, when I say wicked echo coming through. Sorry, Robert. I don't know why. I don't have my phone. Is everyone having an echo problem today? I don't know why that would be. No. Okay. Well, no echo here. A lot of no's coming up, so I'm not going to worry about it. Thanks, folks. Appreciate you jumping in. Just got better. Okay. Maybe there was something, or who knows, right? Technology. Some days goes right over my head. I need my 5-year-old grandson sitting next to me to help me out, because he can, I'm sure. Anyways, so I got a new sheet of paper. You'll notice, I think you know what I mean by that. And so I'm in the Hydronic tab, and I'm going to build a very quick system by dragging and dropping and connecting components, putting the load in, and whatnot. So let's just do a chilled water system today, because that's what I feel like doing. Here's the icon for the air-cooled chiller. There's also one for the water-cooled chiller. So I'm just going to go to get a standard, no manufacturer centrifugal chiller, drag and drop it on the screen. So I just clicked on the component I wanted, and I brought it onto the screen, and I just click. So it's a heck of a lot easier using a mouse with this software, in my opinion. So just keep that in mind. So there's the icon for the chiller. If I double left click on anything on the screen, it brings up the property box of the chiller or any other component. And this is where all of the information associated with that component is visible, okay, and changeable and whatnot. So winter heating data shown for winter heating. Well, we want to go to summer cooling, and notice it says leaving temperature 44 degrees. Well, maybe you want to change it to 42. And if I hit apply, notice it says 42 now. And maybe I want to get rid of the winter one, and I hit apply. You can do that. So you have a lot of flexibility here as you go, right? So keep that in mind. Notice the system load. This is something that people sometimes get wrapped around here. You may think, or you may, for your design, have a good idea what the load is for the building. Well, look, you cannot. So maybe it's 5 million BTUs. Notice I'm trying to type in here. It won't let me. The software has to total up the loads of all of the components you put on the screen in order to get the system load. So you just can't put it in at the generation, what I call generation equipment. In this case, the chiller or boiler or other pieces of equipment like that. So keep that in mind. Sometimes people, think about that, or they try to do that, and it won't distribute it out to the thing. But I'll show you some shortcuts. But nonetheless, keep that in mind. And the other one here I want to show you is load portion, 100%. So many times on projects, you may need to design it for future load. I cannot go above 100% with this here. If I put in 105 and I hit apply, enter a number between 0 and 100. So just keep that in mind. So the workaround for that is to add a dummy load for the future. Think outside the box, and hopefully you can understand, what I'm talking about. And I'll show you what I mean by that as we get going. So, and then look at right here. And again, this is common. I'm spending a little time on a property box, but it's very important to get familiar with these, because this is where all the information is available, changeable, and whatnot for anything on the screen, okay? And notice right here, component head loss design, 15 feet. Well, all of us, I'm assuming all of us realize that in order to do the calculations for the pump for flow and head, or excuse me, for head anyways, you need to get the system resistance of the system. Well, there's the default value for the chiller, 15 feet. So it's going to include 15 feet in the head loss calculation when it calculates the head and flow for the pump. All right, and you can change it if you'd like. Let's see, can I change that? Yes, see, so I very quickly I changed that to 25 feet. You know, so you as the engineer, and this is something that I need to emphasize. I can't emphasize this enough. You have total control of the values in the software. The software has what I call default values in here, right? It has to have something in order to do these calculations, but you can manipulate, change, update, or whatever, all of the values to better represent the system that you're trying to design. So keep that in mind. That's very, very important. I think it allows us. We're engineers. We want to make sure we're doing things correctly, but we want to understand, or at least I think we should understand the software a little more, and this kind of gives you some idea how easy that is. So just keep that in mind. So I'm just going to hit cancel, and notice it went back to 44 because it didn't keep that in there. Anyway, so now I'm going to put some loads on the screen. Again, there's all kinds of icons up here. Spend some time if you ever work with the software. We'll look at some of these, but I know I want to go over here to the hydronic cooling impose load. I'm going to click on the down arrow. I can get a building, and I will at one point, a process. There aren't many processes in here. It's not really an industrial program, more or less, but some of these things may need some chilled water or hot water. So that's why there's some icons for those. But I'm just going to get terminal, coil, and I drag it and put it on the screen. And then I can copy and paste another one on the screen. And notice, in order to, the first time you want to bring something on the screen, you got to click on the down arrow, go to the item, and click on it. The software remembers what you chose. So next time, if you want, I'm just showing you some little shortcuts here. You just click on it and you can bring in the same component onto the screen. So just keep that in mind. Just some little shortcuts that you can do there in that regard. And notice they're all kind of mishmashed over here. So watch, I can draw. I'm just going to left click and hold with my mouse. And these green icons mean those components are active, so you can do something with them. In this case, over on the left-hand side, there's an icon or whatever you call these things, align left. I'm going to click on that. And if I go right above it, space evenly top bottom. So I can make my drawing, excuse me, my drawing or design look neat, right? Looks neater than it did when I just put things on there. And I can move them around if I'd like. So, pretty straightforward in that regard. So now I'm just going to connect from the chiller. I'm going to draw some pipe from the chiller to these loads, okay? Very, very easy to do, very easy to do. Just checking something, make sure I had something turned off. So the pipe drawing icon is this broken arrow up here, connect 90-degree angles, okay? But you can also just put your cursor see my cursor right here is scooping around. If I put my cursor on the pipe or that little arrow and I left click and release, you can see I'm starting to draw a pipe around the screen, right? And then every time I want to change directions, I can left click and release, left click and release. It's very, very easy to draw a pipe once you get used to it, okay? And so now I'm just going to the inside. Notice the pipe now, the inlet. Notice now the pipe right now is all black because there's no loads in here, right? Over at the chiller, 0 BTU, 0 tons, 0 GPM, and there's some zeros over here on the coils as well. And then I can come out of here and find my way back into the chiller pretty quick and easy as well. So once you get used to it, you can do this very, very quickly. Just got to be careful. You got to make sure you go from the ins to the ins and the outs to the outs, or you'll get some dotted pipe. Dotted pipe is not good. No. Dotted pipe is not good. So just keep that in mind. Pretty straightforward though. And if you want to, if I click on this piece of pipe and I put my cursor right over it, I can move it up, right? You can move things around. You can move the whole piece or whatever. So it's pretty straightforward in that regard. So I'm just trying to give you some ideas there in that regard. Let me I know what I want to do in the future. That's why I'm doing what I'm doing. Okay. All right. So before I build the rest of the mechanical room, excuse me, I'm going to put some loads in. Okay. So just like I accessed the chiller property box, I'm going to access the property box for one of these loads. Impose cooling load -1. I double left click on it, key data tab. Notice there's a bunch of tabs here, right? And I'm not going to really spend too much time in the other ones, but nonetheless, here's the tabs. Here's the information, the key information for it, right? Summer cooling, usage cooling, load 0, right? And it's kind of give me that load, give me that load. Temperature change, this is where you would do your delta T at 10 degrees. Well, maybe you want 12, so I'm going to change it to 12. Okay, there's your head loss, 5 feet, so it's going to include a 5-foot pressure drop through that component. And again, you can change that value if you'd like. And I'm just going to put in maybe 50,000 BTUs. It shows you the component flow, so it's starting to do calcs for you. And watch what happens on the screen when I hit OK. Boom, bingo, bango, bongo. A lot of things have changed, right? There's some blue pipe on the screen, and there's that shading, right? Dark and light. And there's that 50,000 BTUs. There's that flow rate and whatnot. So that's how quick it starts to do the calculations. And like I said earlier in today's presentation, it starts the software has to add up the BTUs or the load for the chiller, excuse me, and it's starting to do that right there and show that information for you very quickly. You can also maybe put these in all at the same time. Maybe these three are the same, so I'm just going to highlight them, double left click on them. Now I'm putting in the imposed load for 2, 3, and 4, and maybe these bad boys are 200,000 BTUs. I don't know. I'm just putting in some different numbers here. And again, I want a 12-degree delta T. I like that value today. And notice if you want to change the description on something, most of the items you can change this. So if I click on this description and I access it, maybe these are AHUs or something. Oh, I'm going to cap locks. I'm doing some cap locking, and I hit OK, and you'll notice that the description has changed. And in this case, I just put in something there, and it still kept this one the same because I didn't change that. So that's pretty straightforward in that regard. So I'm going to very quickly build a mechanical room here. What I mean by that is I'm going to add a couple pumps, an expansion tank, and a air and dirt separator. So again, I'm in the hydronic tab. I look at this item that looks like a pump, the base mounted pump. I click on the down arrow. Of course, I'm going to select TACO. Why wouldn't I? And I'm going to click on KV series. And notice what happens here, right? The water is actually flowing left to right. The pump is in this direction. As long as it gets there and I click, it jumps and flips around. And look, it already is displaying flow and head for you based on, and we'll look at that a little greater detail. But nonetheless, that's how quick it does these calculations. That's hopefully someone in your office does on projects. And then I can copy and paste, put a second one on the screen, right? There's my dedicated standby. Pretty straightforward, right? These two are both at 100%, right? Pump 1, pump 2. And then let's see, maybe I'll put in an air and dirt separator and an expansion tank. All right, so we always suggest the expansion tank goes on the suction side of the pump, right? Good question, Rand. I'll answer that in a second. All right, but you can put it any place you want, and that's one of the drawbacks. one of the drawbacks is one of the one of the things I need to discuss about the software is it's only as good as the person that's using it. So today it's not very good because I'm using it. But if you guys use it or you gals use it, you need to know what you're doing. Okay, it's not gonna, for the most part, tell you that you're doing something wrong. So, I'm saying, I want to put this right here, okay, and just so it jumps in right there. You could put this any place you want on the screen, and the software won't do that. So keep that in mind. Excuse me, the software won't give you a note saying, "Hey, idiot, you're doing something wrong." So you need to have some knowledge of an HVAC type of system in that regard. So I'm going to add one more component here, a Taco 4900 air and dirt separator, right? These are the inline air and dirt separators, and please, these are it's a coalescing type, very, very efficient in eliminating air and dirt. We're not the only folks that offer them in the industry, but they're very, very helpful to HVAC, closed loop HVAC hydronic systems to eliminate air and dirt from the system. Okay, and think about how dirty systems are during startup, right? As you start up a system, this type of unit, even though you put strainers in there and this unit here, after 10 rotations of the water going through the system, will get it down to like microns. It's phenomenal how good they are. And again, we're not the only ones that offer these, but talk to your Taco rep to get more information about these. But watch the head loss when I drop this in, boom. So it added that head loss in there. So one of my, I have a question here. He's following along. Rand is, when I try to connect chiller to the coils, I get a circ pump and closely spaced T's automatically input. How do I simply just connect piping? Rand, I believe when you download the software, that feature is automatically turned on. So it does that when you connect to a coil. That was help people design single pipe, what we called single pipe systems, load match system. But you can turn that off, okay, Rand? And others, if you go up to, make sure I go to the right spot. That's what I actually was checking. If you go to edit and scroll down, you'll see near the bottom it says Taco load match design primary secondary. If there's a check mark there, you've got to click on that so it doesn't show that. Excuse me, so there's no check mark there. Okay. Otherwise, if you have a check mark there, it will drop that in for you when you connect to a load. And then if you want to make sure you can turn that off every time you turn on this, open up the software, you double left click. So you've turned that feature off, right? Pretty straightforward how to do that. And you click set project printer paper defaults, blah, 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 blah. And click on that and hit OK. And every time you open a software up, that'll be turned off. So you don't have to do that each time. Okay. I'm going a little quick, but nonetheless, I think you folks can kind of follow that. Hopefully that answers your question, Rand. All right. I downloaded Taco software. Yes, there was a gentleman that was the go-to guy. He's no longer the go-to guy. But anyways, hopefully you can get something out of it now. Can you do parallel pumping? We'll try to figure that. Oh, fixed it. Thanks. Rand said thanks. We'll show you some parallel pumping. Can you define elevations for equipment? Okay. How can I say this? Most of the HVAC hydronic systems are closed loop. So the elevation really doesn't matter. What did he say? What goes up comes down, okay? So if it's a closed loop system and it's 20 stories, yes, there's pressure, and you got to make sure that all the pressures are taken care of. But the software really doesn't need to know that to figure out the flow and head. Yes, it needs to know lengths and all of the what's it's pushing through. But if it pushes up 100 feet, it's coming down 100 feet and it's closed loop. But if it's an open loop system, when I do a closed loop, when I do a chiller, water cooled chiller, I will show you how you can do that. But for the most part, the elevations don't come into play for most of this program use. And someone's asking about parallel pumping, and the answer is yes. And I could actually talk about that right now. So we have a simple system here. Oh, wait, here, I want to wow the crowd, okay? So all the pipe is blue, dark and light color. I want to, the pipe, as soon as there's flow through a pipe, the pipe is sized, but I'm going to display the pipe diameters. So I need to activate the whole drawing. There's different ways to do that. The way I do it is I hit Control A, right? Control All, right? Notice all the green grippers or boxes or whatever you want to call them. I call them green grippers. I don't know. It's just what I call them. Right click, go to connector annotations, diameter, and there's all your pipe diameters shown. Excuse me. I got to take a sip of water. Water, some good water. H2O. That was a good movie, that H2O. What was that movie with the football player? Oh, Adam Sandler. Oh, that was a good movie. He liked his H2O. That was a good movie. Anyways, I'll show you how it sizes the pipe based on flow and what the default values are in there. But to answer the question about parallel pumping, notice right now we have two pumps in here, right? We have two pumps in here right here. And right now they're both at 100%. If I double left click, well, let me on one of them and make sure I'm in the key data. Notice it says flow portion 100%. I can put it at 50%, and I can put this one at 50%, and all of a sudden you have parallel pumping. So the answer to your question is yes. So that's what you can do. Okay. So it's really easy to do parallel pumping there, and maybe you might want to have a third pump here as your standby or whatever, but a pretty simple system in that regard. Matt's asking, can we give the program pipe size? Well, let me get into the pipe sizing right now, such as velocity in the pipe must be 5 feet per second or less. Yes. You want to see how? All right, so let me, this first piece of pipe downstream of the pump, I'm going to double left click on it, of the pumps, and key data tab. So I'm on a pipe property box, and here's the criteria it's using for sizing pipe. 8 feet per second, head loss 4 feet per 100, fitting factor, we'll talk about that shortly. So you can change this 8 feet per second to 5 if you'd like. Hit apply, and now that pipe is 3-inch instead of. And what's handy though is it shows you the actual velocities in there. So keep that in mind. I'm going to go back to 8 for today's thing. Okay, so let me show you this too, Matt. It depends on what pipe diameters you might be concerned about. But if I hit Control A, all right, Control A. Let me try it again. All right, there we go. I hit Control A. I right click. I go to Property View. So now I have access to globally change all of the components if I'd like, instead of one at a time. But notice right here, it says Pipe Hydronic. So if I click on this one, it's every diameter of pipe. If I click on any of the other ones, it's just that diameter of pipe. So if you wanted to change that value for all of the pipe, you would click on this. But if you wanted to just change it for a certain diameter, you would just click on those. So hopefully that gives you some headway into what the answer to the question that you were talking about. So anyways, pretty easy to do, but it is important from a design standpoint. So again, I want to show this, right? Key data, 8 feet per second, pretty common in our industry, right? 5 is a little low, maybe more for domestic or some of the smaller pipes. But most of the time, for most of the projects I see, 8 feet per second, or the charts or whatnot that you can get online for pipe sizing is a pretty common number. And then maximum unit head loss, it's showing 4 feet per 100. So it won't give you a diameter of pipe that would have a higher head loss than that. So in this case, it's showing 2.9 feet based on roughly 108 GPM going through it, and it has selected a 3-inch piece of pipe. And notice if I click on this, I can actually change this. Excuse me, I'm going to change it to 2.5. So the velocity is not too bad. It's getting up there, but notice the head loss now on a 2.5-inch piece of pipe is pretty substantial. So it may affect your head loss, or it will affect. It could affect the horsepower on a pump or whatnot, pump selection. So nonetheless, but you can do that and very easily. And here's the other important piece of this puzzle is there's a pipe fitting factor. So the software does not really keep track of elbows. Even though it looks like there's an elbow here, that's really just a continuous run of pipe. It happens to look like an elbow, but it's just the way it's drawn, okay? But length, right now it's 0. All right, so watch, I'm gonna put in 200 feet. All right, pipe head loss is 5.7 feet, right? Fitting factor of 50%. So the total head loss that's going to come up on that pump is going to be 8.6 feet. So not a bad thing that the software uses. You can change that value. So watch what happens when I hit OK. That 27 went up by 8.6 feet. So that's how easy that is. And by the way, for some of the doubters in the on the call here, you can actually click on, where is it, head loss? Fittings. If you click on fittings, this is where there's that calculation method, input fitting factor. There's other ways you can do it, okay? And one of them is to input the head loss so you can count fittings if you'd like. Go at it. Maybe you want your you have a co-op sitting next to you. Maybe they can do that and do that. But I usually, most people I see use the software are comfortable with the fitting factor in that regard. But nonetheless, you can go a little more detailed if you'd like. That's really up to you. And by the way, there is material of construction. It defaults to steel, but there's a whole bunch of other pipes in here. And again, you can change them per diameter or whatnot, or globally based on what I showed you just a few minutes ago. So pretty straightforward in that regard. So just keep that in mind. And by the way, since I put in a length here, if I right click on this piece of pipe and go up to connector annotations and click on length, you can display that length if you want to keep track of where there were lengths in there. And then you can actually click on it and change the font and all that stuff on that and whatnot. So keep that in mind. Pretty straightforward. You can also add a lot of detail to your drawing if you'd like. So if I click on the hydronic tab here, notice hydronic two-way control valve. I'll just get a little ball valve here. I'm going to put it on the discharge. Again, it flips it and puts it in automatically. Maybe I can get some shutoff valves. Put those in. Pretty straightforward. I think is there a, what's this, a hydronic strainer? Oh no, I don't want to do that. I don't want to put that in there. Oh, how about a balance valve? I could put a balancing valve in there. Oh my goodness. You got all kinds of things in here. What is this, an air vent? Yeah, I got an air vent. I'll put in a little air vent in there too. So you can make a lot of details here. You can add a note to your drawing. I right click, I go to text annotation, and maybe I'll type it typical, and I'll put that right there. So you can start to see some of the details that you can put in there as well. So I'm just gonna, just to give a little more head loss in the pump, I'm just gonna property view, pipe, edit, key data. I'll just put in like 20 feet for all of those lengths of pipe, so we have a little more head loss in that regard. And let's see, I'm going to put these two pumps back at 100% as well. And this is a very handy stuff. This is a very handy screen to go to. If you double left click on it and click on show head loss path, it actually shows you the head loss path that it's calculating at. And that's very, very handy when you get towards the finish of the project. So just keep that in mind if you want to do that. So as an example, if I double left click on this one, go to key data, and I'm going to change this to 150 feet, right? I'm just making something up here. Now I click on that pump and do show head loss path. As you can imagine, right, it changed to go through here with the head loss path. So just keep that in mind. It's pretty handy in that regard. I'm just going to change that back. That's a little wacky. So someone's asking about full load. Does the TACO software assume that all units are running at 100% load when calculating total system GPM and pump size? Yes, it does. Is there a way to input a diversity factor or account for partial load conditions in the software? Yes, there is. If you go to the chiller, instead of load portion, you would put in what percentage you want there. It's not as flexible as you may think, but so maybe you think it should be 80% instead of 100. You put that in there and notice things change on the chiller. You would have to change that on the pumps as well. So there is a workaround for that as you get involved with the software. I'm going to put it back at 100%. That's very important to take into account because a lot of times the sum of the loads, and this sit down when I say this, right? The sum of the loads is bigger or more than what you would expect for the chiller or the boiler. And you got to think outside the box a little bit. And trust me, I know those are scary words, trust me, but nonetheless, many times the sum of the loads is bigger than what you would expect there, and that's how you would take that into account in that regard. So just keep that in mind. And remember I said a dummy load, so say if you wanted something in the future, if I just copy and paste and put something someplace in the load here, in here, depends where it's going to be. I can flip this around. Hold on, I think I can flip it around. I could connect it to the, oh boy. And there's my future load, right? And then I could, if I click on this, wait, I bring up the property box, go to description, I can type in future. So I did want to at least show you that you can do that. Again, remember you can't just do it at the boiler. So that's your kind of workaround for having a future load. So I'm just going to delete that in that regard. The software will also select equipment for you. So if I click on a piece of equipment and go to selection and hit select, it has selected a KV 2007D 3 horsepower pump, and there's the MPSHR. We've talked about that in other webinars, net positive suction head. So nonetheless, you can start to see how quick you can start selecting components with the software. Pretty neat in that regard. You can also, let's go, if I go to, I'm going to show you how to do this, but if I go to, where is it? Am I on the right screen here? Coordination file options. Those are 3 big words. And then, right here it says both. So if you click on schematic DXF and hit OK, and then go file, save as. I'm going to go to my desktop, I hope. Where's my desktop? I'll just leave it at project 2. You can name the project as you would like. Hit SAT, and then if I go back to file, open coordination file, there's that, you could save it as a DXF. So you have that luxury, pretty straightforward. So let's show you some other quick ways to use this software. If I go to File, New, and click on Wizard, there's some Hydronic wizards here. Hydronic System Wizard, Subloop, Hydronic Generation Wizard. What's that mean? Let's click on that. All right. Let's answer some questions here. Well, this time we'll do a heating only load. Flow direction to the left. That's okay. We'll just put in a boiler. That's all right. I'm not going to put any heat exchangers in or anything else. Let's put in 3 boilers at maybe 50% each. Who knows? I don't know. If you had a preferred manufacturer, there's quite a few in there, or whatever. Fluid type, I'm going to leave it at water, but I didn't point this out before. You can, and it's very important on systems to put in the right type of fluid. So maybe if you got a tower outside or something, you might want to make sure you put the glycol in there, or you have to put it in there. So that's regard. So keep that in mind. Leaving temperature 180, maybe it's 140, so I could put that in there. Hit next. I'm going to do some, well, let's do a primary, secondary. All right, hit next. Primary pumps. Let's see. All right, the primary pumps, the one attached to the boiler, I'm just going to put in a little KV. These over here, I'll put in 3 at, someone asked about parallel pumping. I'll do parallel pumping. And so instead of a vertical, just to show you the difference, what the icon looks like, I'll put in a base mounted. Hit next. We'll put some valves in there. Expansion tank, 4900. Not going to save it. Hit finish. And look how quick you can design a system or a mechanical room for you, right? So there's your 3 boilers, right? Maybe 2 at 50%, a backup, N plus 2, whatever, N plus, whatever you call it. And then your 3 pumps here. In that regard, I can go to the hydronic tab. I can get a picture of a building, right? I could put that on the screen. Let's see, this is the inlet. Well, it's going to be the inlet going in, so I got to make sure I go to the inside inlet side. I can come around here. All right, this is the primary, secondary, so each boiler has a pump. There's our secondary or building or loop pumps, right? I'm going to double left click on this, go to the description tab, right, and maybe put in 3 million BTUs. Oops, why did I put that in there? Hit OK, and there's a good start on a project. I can hit Control A, connector annotations, diameter, and there's your diameter shown. And notice it's showing 5-inch pipe. Well, maybe in your area they don't use 5-inch pipe. You don't want to use 5-inch pipe. You double left click, I can turn that off. Let's see, I brought up the project property box. Usually you come into description. This is where you name your project. But if I scroll down, where I always forget where this is. Oh yeah, excuse me, hydronic pipe. This is where you could change the type of material. If I click on unclick 5-inch, hit OK. Well, what that 5-inch went to 6-inch. Oh, good, it went up, didn't go down. So that's important. So you can see how quick you can get a head start on a project. Nothing's going on in this school yet, right? Nothing's going on in here, but nonetheless, you can start getting some information, discussions, and I did that in what, a minute or something. And once you get used to the software, you can even do it quicker than that. I do need to show you and call out something that's very, very important on the software. So this is a primary, secondary system, right? And we've had some webinars. Rich does a great job explaining the flow direction in here. It depends on what time of day it is and how many boilers are on and pumps are on and all of that stuff. But nonetheless, you can get flow in a lot of different not a lot of different directions, 2 different directions, or none at all. But so if I click on this, see this pipe is green. If I click on it and I go to key data, make sure you're in winter heating, right? Notice it says flow direction. The software has set it at dual or decoupler. Let me show you something. Zip, 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 zip. I'm trying to get it out of the way here. If I go back to most of the time, it's automatic. So I put it in automatic and I hit OK. Oh boy. Well, you know what? I got to do it for both. Software. All right. So if you draw a system right? Without using the wizard, primary, secondary, just remember you've got to go in and set the flow direction in the pipe, okay? And that's very important, or else the software will not calculate everything correctly. So notice right here, flow direction, and you could say left to right, right to left, none, automatic, but in this case it's dual or a decoupler. And we talked about that, right? The decouplers, closely spaced T's. There's a lot of different words out there in the industry for this. You got to do it for both. With their heating, put them in decoupler and hit OK. And now that pipe is green, and it's allowing you to do that. So that's your primary, secondary in that regard. Did I show the pipe diameter? Yes, I did. Very, very quickly, you can really do that. Someone said not really primary, secondary. Is that too much distance between piping? I guess it's all in the eye of the beholder. If you think that's the case, how about if you do this? There, is that better? That make you feel better? I mean, it's just a drawing, so that's if you want to put a note here, this is a closely spaced T's, primary, secondary, your decoupler or whatever. You can do that very quickly in that regard. Let me see if I can get an arrow here, right? And if I draw that in, and then maybe you add the word decoupler, hit OK, and boom, you can put that in right there, or whatever. You can do that very quickly to try to make it a little less confusing. So I don't have a lot of time left, so I did want to show you at least the wizard and draw a hydronic cooling only. And this time I'm going to do a water-cooled chiller. I kind of mentioned I would do that. Again, I'm not going to add anything else. I'll just put in a couple chillers. I'll leave it at 100%. Again, fluid type water, but nonetheless, you can change that. Leaving temp, there's your towers. I'll put in a couple towers, blah, 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 blah. Open circuit, that's fine. So maybe this would have the propylene glycol at 30%. Salt Lake City's leaving temperature is 80 degrees, so you may need to change that to what it is. Most projects I see 85. Cooling, primary, secondary. We'll use a hydraulic separator this time. This isn't actually a fabricated piece that guarantees that it's done correctly. And then we'll do manifold primary. Next. All right. Just put in a couple pumps. Trying to get through this quick here. So there's your chiller layout. And instead of that green pipe this time, there's that prefabricated piece, Taco 5900. You can actually put Paul rings in there, so it can actually eliminate air and dirt as well from the system, and maybe help you in that regard. There's your two pumps over here. If you click on the tower, you could actually add component to tower top, so you could actually add some height there if you'd like. So pretty straightforward. And again, right, you can go back to the hydronic tab and get a picture of a building. I keep having to move stuff around. I'll just get a high rise, right? Put that in there. I'm just trying to show you some of the things you can do with this software. Pretty straightforward in that regard. Right now it's off the paper. I'm gonna move that back in. And notice it adds a second sheet of paper. So just keep that in mind. Once it's connected up, I didn't put a load in, right? Put the load in, gotta go to cooling. Hit OK. And there's that control A again. That's one of the most important things, right? You can wow the crowd. You can wow the crowd very quickly by doing that. Again, no pipe lengths in here or anything like that. So just keep that in mind in that regard. Someone's saying, what distance do you recommend for the decoupling? Closely spaced tees. It all depends on the pipe diameter. But put the two tees pretty close together in that regard. I forget the exact dimensions, but instead of that, put in a 5900, so you guarantee that they're spaced correctly in that regard. So let me show you something else. File, open example. There's a whole bunch of examples in here that gives you a lot of more ideas, but watch this, details. Detail sheets. Good Lord. Hydronic details. Hit OK. Notice how detailed you can get with this software, right? And this isn't going to replace some of your detailed sheets, but nonetheless, and you can copy and paste these and use these all you would like very, very quickly in that regard, right? So like if you wanted to use this detail, you just copy it. Wait, I have another window open, right? Obviously, I just opened up the wrong one here, but and you can copy and paste it right back on there, and you could use that if you'd like. So pretty handy once you start getting used to it. And notice over here, it actually shows you. So these are actually the default flow rates for each of the up to 8-inch pipe. And it goes up higher. I mean, there's really no limit. I think I seen the project with 24-inch diameter pipe one time. So just keep that in mind. One question that comes up every once in a while, like maybe your company has a different icon for a butterfly valve. You cannot input that into here. You have to live with the pictures, the icons, pictures, whatever you want to call them, that are in the software. So just keep that in mind. And again, you can download it from our website. Right, pretty straightforward. It has to live on your computer, or you can go to, I did say I was going to do this, right? HVACsolution.com. So here is their website, HVAC Solution, no S, right? All one word, .com. And they have some other products and trials. If you can contact them if you want to get some information or a seminar or a webinar on the software to design airside systems and whatnot, or steam systems. Oh boy, steam systems. There's probably 2 people on the call that still do steam, if that. So just keep that in mind in that regard. And like I said, you can download a free trial of this software, but again, they do charge for it, and you can get prices up here and whatnot. So that is their that's their stuff here. Our icon is this green and white one right here, and that's what you would use for ours there. So I am winding down. That is a clean sheet of paper. Notice there's all different icons up here and whatnot, but we've had some great questions. If there's no other, I got a couple that I'm going to answer offline here, but nonetheless, other than that, I'm going to, it's getting close to 1 o'clock, and if there's no other questions, I'm going to start saying goodbye. So long, farewell. That was another good movie. Sound of Music. That was another one that I liked. That was quite the movie. Julie Andrews was one of my favorite. Still is one of my favorite. Who could ever forget supercalifragilisticexpialidocious? So, anyways, other than that, I do appreciate everyone's time. I did at one point have up the other Taco Tuesdays. Let's see, is that what we're showing? Yeah. So in a couple of weeks, oh no, maybe even longer than that, August 5th. What's today? I don't even want to talk about August 5th. All variable chilled water plants. Keep that in mind. Other than that, you're welcome, everybody. Appreciate it, but I am going to sign off. Summer Vacation. I know what you mean. That was a good movie too. or a vacation. Take care, everybody, and we'll see you down the road.